Here's section 4-4 where we talk about CPCTC. What does that stand for? Corresponding parts of congruent triangles are congruent. But first, a little review. In 4-1, we talked about congruent polygons, and the definition of congruent polygons were polygons with corresponding sides that are congruent and corresponding angles that are congruent. A triangle, of course, is a polygon that has 3 sides and 3 angles, so that's 6 parts, right? Then we get to section 4-2, and we came up with 4 ways to do something special. Here's what we were doing. We started with 2 triangles, then we showed that 3 out of those 6 parts, 3 out of those 6 corresponding parts are congruent. Then we can state that the 2 triangles that we started with are completely congruent. So what could you possibly do after that? Well, we'll use CPCTC, but first, do you remember what those 4 ways were for section 4-2 and 4-3? Side, 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 angle, side, angle, angle, side, and angle, side, angle. So these 3 parts have to be corresponding and congruent to 3 parts from another triangle. Then the entire triangle can be made congruent. And once you've established that, the remaining 3 parts that we didn't talk about, those are the parts that we're going to care about today with CPCTC. Let us begin. Here's what CPCTC stands for. Corresponding parts of congruent triangles are congruent. Oh, look at that. They're looking for things that are congruent triangles. The only way to get congruent triangles was with our SSS, SAS, ASA, and SAAS. So that means that we can take one more step after we've done that, hey, these 2 triangles are congruent statement, and then talk about the parts that we ignored or didn't know anything about at first. So here's an example. We're going to make some congruence statements here. The diagram shows the frame of an umbrella. And what congruent statement besides angle 3 and angle 4 can you prove from just the diagram? Now, let's take a closer look at what was given. S to L is congruent to SR. And look at that. They put the little hatch mark. And they also tell you that 1 and 2, angles 1 and angle 2 are congruent. So those guys right in there. So now we can actually say that this side, SC, from S to C, is congruent to what other side? Well, yeah, it's sort of obvious. We're going to talk about RC. This side, SC, is going to be congruent to something else, and the reason we're going to say that is the reflexive property. Oh, I got this. Reflexive property always means the thing is congruent to itself. So SC congruent to SC. Great. Now we can make the statement that the entire triangle is congruent. Well, what did we prove here? What parts did we address? We talked about a side, we talked about an angle, and then we talked about another side, corresponding, of course, to the things on the other side. The side, the angle, and the side. So we used SAS. But what about all of the other triangle parts that we didn't even talk about? Oh, they got left out. Well, hey, we can actually talk about angle 3 and angle 4 now because we've proven the triangles are congruent. And what's the definition of a congruent polygon? The corresponding sides are congruent and the corresponding angles are congruent. So we know that these polygons are congruent, these 2 triangles are congruent, so the other things that correspond must also be congruent. So you can form congruence statements about all 3 pairs of corresponding angles and now all 3 pairs of corresponding sides. So here are the congruence statements. SL congruent to SR. We were given that. SC is congruent to SC. So that means we're looking at the triangle on the left compared to the triangle on the right and matching up the stuff that we've got. These are congruent because that's the reflexive property. Then how about the other side? CL is congruent to CR. Now, why can we say that? The diagram didn't show it to start with, and we didn't talk about it anywhere in this little SAS proof. Here it is, CPCTC. These are corresponding parts from congruent triangles, because I already proved that they're congruent. So these corresponding parts from the congruent triangles are congruent. Now let's talk about the angles. I gotta zoom out here. Angle 1 and angle 2 are congruent. Why is that? Because they told us. And then angle 3 and angle 4, those are congruent, but why? They weren't anywhere in this part of the proof where I talked about a side, an angle, and a side. Oops, a side, an angle, and a side. These were two angles that I didn't even use. So that means that I must have used CPCTC. These are corresponding parts of triangles that I've already proven are congruent. What's the last pair of angles here? We've got this one in here, congruent to this one in here. So I'm going to call it CLS is congruent to angle CRS. And how come? Well, those are corresponding parts of congruent triangles that are congruent as well. Continuing on to page 33, we have this funny thing about Napoleon and estimating the width of a river. You can read through this. Here are the blanks to fill in. The comments about right angles are important, but we're going to really get into the right angles in the next couple sections. So here we go. The officer must stand perpendicular to the ground, and the ground has to be level or flat for Napoleon to be able to do this. Napoleon was a smart guy, but we'll come back to him. So let's do a proof. We are given some information. Oh, look, two angles are what we're given, and we have to prove that one of these sides is, one of this sets of sides is congruent. So let's label this a little bit. Q and R are congruent. So I'm going to use smiley faces where Q and R are. So smiley faces are corresponding parts. Then we have this other angle QPS congruent to RSP. QPS, that means this one. They're using arc marks. I'll use a star. Congruent to RSP. Oh, there's the matching arc mark. And here's the other star. So let's see here. We've got an angle. We've got, the next thing I know about is an angle. And anything else that jumps out at you? Yeah, SP. What's special about SP? Yeah, it's congruent to itself. So we're looking at an angle, side proof here. So let's write this out. Here are the statements. Here's the first statement. These two things are true because they're given to me. The second thing we can state is that segment SP, that one right in the middle, is congruent to itself. And that would be the reflexive property. So now we've got angle, side. So I can write this entire triangle, RSP, is congruent to the other entire triangle, QPS. And why can I say that? Because I have proven to you that there is an angle, and a side in that order that are congruent. But what we really needed here was SQ congruent to PR. SQ and PR. That wasn't mentioned anywhere in there. So how can we say that those are congruent? Hey, that is the missing, one of the missing sides and angles that we needed, that we didn't get on this original angle side. So here's my fourth statement. SQ congruent to PR, because all of the other parts of this triangle are congruent. That must mean that these corresponding parts are also congruent. Oh, that sounds like something we just learned. Corresponding parts of congruent triangles are congruent. Now they're asking for a little bit of math here on number 2. Recall our Napoleon example. How wide was the river if the officer paced off 20 paces and each pace was 2.5 feet long? So that means the guy's walking along, and every time he moves from one foot to the next, that's one pace, but each one equals 2.5 feet. So if he had 20 of these, then we need to multiply that by 2.5 feet, and we get an answer of 50 feet. Done.